All right, so we're going to apply what we learned in the previous lesson to today's lesson because we are going to use the wave rules to solve polynomial inequalities, okay? So the wave rules should be the same like before. This time we have the inequality rules, which we've already talked about all year, right? We talked about the greater than symbol, the less than symbol, the less than or equal to, and the greater than or equal to. We talked about open and closed dots, and we talked about regular parentheses, square brackets, yada, yada, yada. Now, this time, since we're involving the wave, the greater than or equal to tells you to shade the portions above the x-axis, and the less than or equal to tells you to shade the portions of the graph below the x-axis. So let's give you an example. I have the x-axis right here, and you already drew the wave, right? So you got your 2 points, assuming that these are, single roots here. And there you go, you have your wave. Now, if you're shading above the x-axis, you need to shade between the actual line, so this is the actual line, and the x-axis. So if it's above, you would be shading here and there. If you were to shade below the x-axis, again, it needs to be between the x-axis and the line. So again, this is the line, this is the x-axis. So you would be shading below right there, okay? We can give you something like this. Let's say you have something like that, right? So if you were to shade above, again, it needs to be between the line and the x-axis. So it'd be right here and there. If you were shading below, it would be right here and there. Okay? So let's go ahead and do some examples. We have number 1. So I always like to look at my polynomial equation or inequality and find my zeros. So here we have negative times x minus 2 times x plus 1 times x plus 4 quantity squared. I'm going to go ahead and rewrite this as negative times x minus 2 times x plus 1 times x plus 4 times x plus 4, because this thing here is just written twice. Okay? So if I were to solve the zeros, I just do x minus 2 equals 0, x plus 1 equals 0, x plus 4 equals 0, and x plus 4 equal to 0. So x equals 2, that's a single root. X equals negative 1, that's a single root. And then here we have x plus 4 equal to 0 2 times. So we have x equals negative 4 and x equals negative 4. So that's a double root. So my single roots, we cross the x-axis. And my double roots, we bounce off the x-axis. Okay? So I'm going to go ahead and plot my points on the x-axis. So we have to be very careful with this one because we're dealing with an inequality. We have to use either an open dot or a closed dot. So here we have a less than sign. It's not a less than or equal to. So if it's a less than sign or a greater than sign, then if I were to plot my points on the x-axis, right? So I start with negative 4, negative 1, and positive 2. They should be in order because this is a number line, or this is the x-axis, so they should be in order from least to greatest, right? So all of these points should be open dots. Okay, so this here, open dots. Now, let's go ahead and figure out what the wave of this thing looks like. Because we have the leading coefficient, so the leading coefficient is negative, that means we need to start bottom right. Okay, so whenever you're applying the wave rules, we always start on the right. It's just you have to figure out if you need to start above or below, right? So the leading coefficient is negative, you start bottom right. Now the next thing is to figure out the degree. So if the degree of the polynomial is even, the ends of the graphs will point in the same direction. However, if the degree of the polynomial is odd, the ends of the graphs will point in the opposite direction. So here we have bottom right. So to figure out the degree of this thing, I would just multiply all of these x's. So x times x times x times x is x to the fourth. And we know that this number here is even. So I'm going to write even. So if this is bottom right, then this other half should be bottom left. Okay, so the end behavior should look like that. So end behavior should look like that. Okay, so here we go. We're going to go ahead and draw out the wave of this thing. So 2 and -1 are single roots, and -4 is a double root. So we're going to start bottom right. We're going to cross at 2. And as I approach -1, I should be able to cross. But when I approach -4, it should bounce off the x-axis, just like that. With a little adjustment, actually. There you go. Okay, so there you go. Now, we have to shade. So since this is a less than sign, I need to shade below the x-axis. So we talked about it over here. When we're shading, it has to be between the line and the x-axis. Okay, so this is where I need to shade, and this is where I need to shade, and this is where I need to shade, right? So that's the x-axis, this is the line, right? And we're shading below. That's one part where you need to shade. Same thing over here and same thing over there, okay? Now, we have to write out our solution. So I have -4, -1, +2. All of these things are open dots. And we're reading this from left to right. So I can see something happening between -infinity and -4. Something is happening between -4 and -1. And something is happening from 2 to +infinity. So that's basically where I'm going to shade, right? So -4 shading to the left. And we're shading between -4 and -1. And then we're shading to the right of +2. So the interval notation, okay, we're reading this from left to right. We have -infinity, comma, -4. So both of these should have the regular parentheses. Then we write union, because there's an interval between -4 and -1. And something is happening from +2 to infinity. So union +2 to +infinity. And we're done. All right, so hopefully you have an understanding on how to do these problems as we progress through the notes. Now, number 2, I know this one's a little weird because we have 3 terms times 3 terms. So we have a trinomial times a trinomial. So what I have to do is factor each of them. So for the first part, I'm going to use the x method. -2 up top, -1 down below. The two numbers are -2 and +1. So I'm going to rewrite this as x minus 2 times x plus 1. And then for the second trinomial over here, I'm going to use the x method, -5 up top, -4 down below, and the two numbers should be -5 and +1. So x minus 5 times x plus 1. So all of these things should be greater than 0. So let's go ahead and solve for the zeros. I have x minus 2 equals 0, x plus 1 equals 0, x minus 5 equals 0, and x plus 1 equals 0. So this one is x equals 2, x equals -1, x equals 5, and x equals -1 again. So we have our single root at x equals 2, single root at x equals 5, and then here we have x equals -1 twice, so that is our double root, okay? So that is our double root. So x equals -1 is a double root. Okay, so here's my wave graph. So we're going to start off with -1, +2, and +5. We have a greater than symbol, so all of these points should be open dots. So open, open, and open. Now, the leading coefficient. So the leading coefficient, it's positive, right? So it's a +1. So we need to start top right. And then I'm going to multiply all of these x's together. So the degree is x times x times x times x, which is x to the 4th. So that's even. So that means both of these ends should be the same. So it should look something like this, okay? So x equals 2 and x equals 5, they're my single roots, and then x equals -1 is my double root. So I'm going to start top right. I'm going to approach 5, we're going to cross the x-axis. I'm going to approach 2, we're going to cross the x-axis. But as I approach -1, it should bounce. Okay? So yes, the ends should be facing the same direction. Now what we need to do is shade. So since it's greater than, I need to shade above the x-axis. So it would be right here, right there, and right there as well. Okay, so let's figure out the solution of this thing. So -1, +2, +5, all of these are open dots. And then we see some shading on the left side of -1. And then shading between -1 and 2. And then some shading to the right of 5. So the interval notation for this is -infinity to -1 union -1, comma, 2 union 5 to infinity, right? So all of these things should be regular parentheses. All right. Let's take a look at number 3 together. We have x squared minus 3x minus 18, which is greater than or equal to 0. So we have 3 terms. We need to factor this guy out. -18 up top, -3 down below. Our two numbers are -6 and +3. So I'm going to rewrite this as x minus 6 times x plus 3, which is greater than or equal to 0. So then x minus 6 equals 0, which we all know is x equals 6. And then x plus 3 equals 0, which is x equals -3. So we don't have a double root, so both of these things are single roots. We're going to cross the x-axis, no problemo. Okay, so let's go ahead and figure out our leading coefficient. So the leading coefficient is a +1, right? It's a +1 here. So we're going to start top right. Should look like that. So the right half of this graph should be to the right and pointing up top. Now for the degree of this polynomial, it's x times x. So x times x, which is x squared. So since it's even, then the other half should be pointing up but on the left-hand side, okay? So our end behavior should look like this. All right, so for my wave graph, we have -3 and +6. Notice that we have a greater than or equal to sign. So that means these dots must be closed, okay? And it's also important to note that since it's greater than or equal to, we need to shade above the x-axis. But let's go ahead and draw out our wave. We're starting top right, and then we know that at 6, I'm going to cross, but as I approach -3, I should cross as well. So it should look something like that, okay? So we're going to shade here and there. So then for our solution, we have -3 and 6. So we're going to shade to the left of -3, and we're going to shade to the right of 6. So our interval should be -∞, comma, -3, square bracket, union, square bracket, 6, comma, +∞. All right? Number 4, we have -x cubed minus 4x squared plus 12x, which is greater than or equal to 0. So for this problem, we need to be careful because there's actually a GCF between these three terms. So the GCF is -x, okay? So first thing, if you see a negative right in front, you need to make sure that you factor that out, okay? So let's go ahead and rewrite this as -x times x squared plus 4x minus 12, which is greater than or equal to 0. So here, this is where I'm going to use the x method. So -12 up top, +4 down below, and the two numbers are 6 and -2. So I'll write -x times x plus 6 times x minus 2, which is greater than or equal to 0. And then now I'm going to set each of these factors equal to 0. So here we have x equals 0, x equals -6, and x is +2. All of these things are single roots. So we know what to do when we have a single root. When we approach them, we cross, right? So the leading coefficient is actually a negative, so we're going to start bottom right. So we have a negative. That means we start at the bottom right. And then for our degree, it is, well, it's right there, right? The degree of this polynomial, it's the largest exponent of the polynomial, which is 3, right? So the degree is 3, and that's odd. So we should be pointing in the opposite direction, okay? So here we have -6, 0, and +2. So we have a greater than or equal to, so all of these dots should be closed. So remember, the leading coefficient is a negative, so that means we start bottom right. So I'm going to go ahead and draw my wave graph. As I approach 2, that is a single root, so I'm going to cross. 0, it's a single root, I'm going to cross. And then -6, that's a single root, I'm going to cross, okay? Let me go ahead and fix the graph a little bit. Okay, so it should look something like that. The end behavior should agree, right? So we have greater than or equal to. So that means we need to shade above the x-axis, right? So we need to shade here and here. We can't shade here because it's actually going down. And if we look, I would not be shading here, nor would I be shading here. But if I were to shade here, that means I need to be shading below the x-axis, okay? So just be careful with that one. Now, our solutions, we have -6, 0, and positive 2. All of these things should be a closed dot. We can see that they're shading to the left of -6. We can see some shading between 0 and 2, and then we should be good. So we have -infinity, comma, -6, square bracket, union, square bracket, 0, comma, 2. All right? So that's solving polynomial inequalities using the wave.